Hello and welcome to our video for the activity 3 of Mass and Energy 2. To start, what is electricity? Electricity is a phenomenon associated with stationary or moving electric charges. An electric charge is a fundamental property of matter and is born by elementary particles. In electricity, the particle involved is the electron, which carries a charge designated by convention as negative. Thus, the various manifestations of electricity are the result of the accumulation or motion of number of electrons. Coulomb law is the mathematical description of the electric force between charged objects. It was proposed by the French scientist Charles Augustin de Coulomb in the 18th century. Charge is a basic property of matter. Every constituent of matter has an electric charge with a value that can be positive, negative, or zero. In Coulomb's law, the magnitude and sign of the electric force are determined by the electric charge. Thus, charge determines how electromagnetism influences the motion and charge objectives. According to Columbus' law, the electric field of like charges repel each other, and the electric field of unlike charges attract each other. The attraction or repulsion acts along the line between the two charges. The size of the forces varies inversely as the square of the distance between the two charges. The size of the force is proportional to the value of each charge, and the unit used to measure charge is the coulomb. Coulomb's electroscope is a device used to detect the presence of an electric charge. An electric charge brought near the conductor or in contact with it causes the leaves to stand apart at an angle. Because according to Columbus' law, the like electric charge either induces in or transfer to each leaf, causes them to repel each other. For this activity, we built an electroscope. We made a hole in the lid of our jar. We twisted a wire and made a coil that goes outside the lid of the jar. And on the inside, it has a hook supporting two aluminum strips. And the wire is held in place with insulating tape so it doesn't move. Now, to demonstrate the function of our electroscope, our teammate Alan rubbed a balloon filled with air to his hair, and when approaching it to the coil of our electroscope, we can see both aluminum strips repelling each other because of the electrostatic charge Alan made when rubbing the balloon. When Alan put his hand on the electroscope and the balloon on the coil, we can observe that after releasing them both, the aluminum strips stop repelling each other, because the presence of the electrostatic charge of the balloon is gone. Now, before concluding, let's explain some questions. How does a body become negatively charged? A body becomes negatively charged when it's given an excess of electrons to it, because electrons hold a negative charge in them. The redistribution of electric charge in an object is known as electric induction. In this case, the electrons are transferred between the hair and the balloon through friction, which electrically charges the balloon through electrostatic condition, in which through gaining enough energy to leave the atom, by the interaction of the electric field of each particle between each other, and the valence electron, which are the least bound to the central positive charge of the atom. The charge of one object is rubbed off and given to another, in this case, the hair in the balloon. How do you call the type of electrification that takes place when a body with an electric charge gets close to another one and electrifies it? The type of energy is static electricity, generated by rubbing two or more objects between them, causing them to build up friction, exchanging electric charges between them, like what we did in our experiment when rubbing the balloon with Alan's hair, and testing its electricity through the electroscope. Thanks for watching.
Sin tocar. G. Ah, ya tocó. Ahora suéltalo, aléjalo completamente. Otra vez. Ahora sí pongo la mano aquí. Sí. Uy. Ah, no, no toca, pero en el video se ve que toca. Gracias. Uy, uy, sí fue muy... Ay, sí.